Hello, welcome to KCS at Home Summer Edition. My name is Courtney Payne and I teach 4th grade math at Bonnie K Elementary School. I am so excited that we're going to review multiplication and division together, so let's get started.
Today we will be reviewing multiplication and division. Let's take a look at multiplication first, which is in our numbers in base 10 standard. I can use area models and partial products to complete multiplication problems involving whole numbers of up to 4 digits by 1-digit numbers and a 2-digit number by a 2-digit number. Now we have a few words in here that are highlighted we're going to go over. So let's look at these words. The first word is area model. An area model is a tool you can use to help visualize a multiplication or division problem. And it is set up in a box like the picture below. The next vocabulary word was partial products. It is a strategy used to multiply multi-digit numbers. The products you get in each step are called partial products. And there's an example of that below. The last one was multiplication. Multiplication is an operation used to find the total number of items in equal-sized group. So if you look at the picture below, we have an array. An array shows that we have 3 numbers of groups because there are 3 rows, and there are 6 in each group, and that shows a factor times a factor gives us a product. So 3 times 6 equals 18. Now, the next word that we need to study is factor. A factor is a number that is multiplied. So if we look, we have the factor of 3 and the factor of 6. It was the 3 rows and the 6 in each row. So both of those are factors. The next one that we need to look at is distributive property. It is multiplying a number by a group of numbers added together is the same as doing each multiplication separately. So if we look at this array, we know that we have 3 groups, but we broke this up. Instead of being 5, we broke this 5 up into 2 and 3. So we can see that 3 times 2 is 6, and 3 times 3 is 9. And if you add those together, you get 15. Now, let's look at an example for an area model for multiplication. Let's read this word problem. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs, each with 28 chairs. How many folding chairs are there? Now I'm a good reader, so I'm going to read that again. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs, each with 28 chairs. How many folding chairs are there? So I know that I'm looking for how many folding chairs are there, which is the total. And I know that I have 16 rows of 28 chairs. So one way that I could solve this, if we look at the picture is you can use an area model to multiply 2-digit numbers. So to solve this problem, we would have to multiply 16 times 28. Well, using an area model, we're going to break up this 16 into 10 and 8. And then we're going to break up this 28 into 20 and 8. And now that I have my numbers broke up and my area model set up, all I have to do is pull and multiply. So I see in this box, I have a side of 20 and a width of 10. So I have 20 times 10, which is 2 tens times 1 10. Well, that equals 200s. So this box has a value of 200. Then my next box, I have a side of 20 and a width of 6. So that's 20 times 6, which is 2 tens times 6, and that equals 12 tens, which is 120. Now I move on down, and I've got to multiply 8 times 10. And 8 times 10 is 8 times 110 equals 8 tens, and that has a value of 80. And then I have a side of 8 and a width of 6 for this last box, and 8 times 6 is 48. Now that I have all these little pieces, 200, 120, 80, and 48, those are called my partial products, and all I've got to do is add them up because they are part of the product. So you can see down here at the bottom where they have wrote them out and then they've added them up. Sometimes I like to line my numbers up. So I would say 200 plus 80 plus 120 plus 48. And notice I have my ones with my ones, my tens with my tens, and my hundreds with my hundreds. So to add my ones, I have 0 plus 0 plus 0 plus 8 ones is 8. 8 tens plus 2 tens is 10 tens, plus 4 more tens is 14 tens. So I'm going to keep my 4 tens, and I'm going to regroup that 100 up here. And then 100 plus 200 plus 1 more 100 is 400. So my answer is 448. And that is one way you could solve this problem using an area model for multiplication. The other strategy that we had in our objective was to use partial products. So let's look at that. We're going to use partial products and the distributive property to multiply. We're working that same problem, but let's reread it again. Folding chairs are set up in a school auditorium for a play. There are 16 rows of chairs, each with 28 chairs. How many folding chairs are there? For our model it, you can also multiply a two-digit numbers using partial products. So you can see we've got it set up nice and tall, 16 times 28. Now the first thing we're going to multiply is we're going to multiply our 8 ones times our 6 ones, and that goes right here. 8 ones times 6 ones, that's 48 ones. The next one is we're going to multiply this 8 ones again, but we're going to pass it out here to the top for our 110. So 8 ones times 110 is 80. So now I have passed out this 8 ones and 28 to both the 6 and the 10. So I'm going to move on to my next number, which is this 2. But that 2 has a value of 20. So I'm going to take my 2 tens and I'm going to multiply it times the 6 ones. So 2 tens times 6 ones is 120. And then my last part I've got to do is I've got to take that 2 tens again, and I've got to multiply it times this 110 up here. So 2 tens times 110 is 200. So now that I have all my little partial products, I've got to add again. So 8 ones plus 0 ones plus 0 ones plus 0 ones is 8 ones. 4 tens plus 8 tens is 12 tens. Plus 2 more tens is 14 tens. I'm going to keep my 410 and regroup my 100. 100 plus 200 plus 1 more 100 is 400. Now, there was another word in there that we saw, and it was the distributive property up here at the top. The distributive property takes everything that we did here, and it just stretches it out down here on the bottom. So as you can see, we have 8 ones plus 6 ones, which is 8 times 6 right here. And then we have our 8 ones times 110, which is 8 times 10. Then our next one was 2 tens times 6 ones, which is 6 times 20. And then finally, our 2 tens times our 110, which is 20 times 10. This is the distributive property. It's just taking what we do in partial products up here and stretching it out longwise. And then once you find all these little partial products right here, you add them up. So for our mathematical discourse, I want you to think about, how can you determine if your answer to the problem is reasonable? I'll give you a minute to think about that. Well, one way that I like to determine if my answer is reasonable is I like to estimate. So when I'm estimating, I'm going to some friendly numbers, and it's going to be rounding. So let's think about this. If we have the number 16, what number is that number close to? Is it close to 20? Or is it close to 10? Well, I know that 16 falls above 15, which would be right in the middle here. So 16 is closer to 20 than it is to 10. Well, let's look at this number 28. 28, is it closer to 30? Or is it closer to 20? Well, right in the middle between 20 and 30 is 25. And I know that 28 is up above 25. Oops, that's supposed to be a 5. There we go. Mistakes happen. We just got to attend to precision and fix it. So 28 is closer to 30, so I'm going to use 30. Now, if I multiply 20 times 30, my answer should be close to 448. Not exact, but not too far away. Either too much or too little. Let's see what we get. 20 times 30 is 600. Well, 448 is not too far away from 600. So my answer is pretty reasonable. Now let's go on and let's look at the activity 1 example problem, so you can get started on your packet. The example says Aaron's guitar lesson is 35 minutes a week. He's been taking lessons for 12 weeks. How many minutes has Aaron spent at lessons? That's really cool. I wish I knew how to play the guitar. Let's look at this again. We're good readers, right? Aaron's guitar lesson is 35 minutes a week. So he repeats that every week. He has been taking lessons for 12 weeks, so he's repeated that 35 12 times. So we're going to multiply to solve this problem because it wants to know how many minutes Aaron has spent in lessons, which is looking for the total. So we're going to use an area model to multiply, which shows 35 times 12. And we broke up this 35 up here on the top into 30 and 5. And the 12 on the side to 10 and 2. Just like before, we're going to pull and multiply. So let's erase these drawings and let's get started. So this has a side of 10 and a width of 30. So that's 10 times 30. Well, that's 110 times 3 tens is 300s. And then we'll pull again. We'll do a side of 10 and a width of 5. So that's 10 times 5. 110 times 5 is 5 tens, which has a value of 50. And then let's move on down here. We have a side of 2 and a width of 30. So that's 2 times 30, which is 2 times 3 tens equals 6 tens, which is a value of 60. And then finally, a side of 2 and a width of 5, which is 2 times 5 is 10. Now we take all our little partial products, the 300, the 50, the 60, and the 10, and we add them up to find the total product. So 300 plus 60 plus 50 plus 10, well, 0 plus 0 plus 0 plus 0 ones is 0 ones. 6 tens plus 5 tens is 11 tens, plus one more is 12 tens. I'm going to keep my 2 tens and regroup a 100. And then 3 plus 100 is 400. So Aaron has spent 420 minutes at lessons. Now the next problem in here, you're going to take what we just did, but you are going to go back and you're going to fill it in using partial products. Good luck. We're going to move on to the next sheet in your packet, which is going to study division. Division again is in our numbers in base 10. And our standard that we're going to look at is B5. And our objective is I can use area models and partial quotients to complete division problems, dividing up to 4-digit dividends by 1-digit divisors with remainders. So let's look at our vocabulary. An area model. Once again, it is a tool you can use to help visualize a multiplication or division problem. So we're using a model just like with multiplication, except for we're going to use it to divide this time. Partial quotients. It is a strategy used to divide multi-digit numbers. The quotients you get in each step are called partial quotients. There is an example picture right down there below it. You have the partial quotients. These little pieces right here are part of the full quotient. Division. Division is an operation used to separate into equal groups. So I have down here 18 total dots, and I am dividing them into 3 groups, and I see that my answer is 6 in each group. The dividend. The dividend is the number that is divided in a division problem. So it is the amount that you have. Right here, we have 20. That is the dividend. You can also look, sometimes it's written like this instead of in an equation. The dividend goes right there inside. The divisor. The divisor is the number you divide by in a division problem. So it could be the number of groups, the number of shelves that you have, the number of people you're sharing with. That's the divisor. If you look at an equation right here, it's this number. And if you look right here, if your division equation is written like this, it's the number on the outside. The next number is the quotient. It is the result of the division problem. It's your answer. So right here, it's on the other side of your equal sign. And your quotient's going to be on the top if your picture looks like this. So let's look at an area model for division. Our problem says, a factory has 2,125 DVD players to ship to electronics stores. They ship 4 DVD players in each box. How many full boxes can they ship? Let me read that one more time because I'm a good reader. A factory has 2,125 DVD players to ship to electronics stores. They ship 4 DVD players in each box. How many full boxes can they ship? So I want to know how many full boxes. I don't want to know if there's any left over, just the full. The factory has a total of 2,125 DVD players. So that's going to be the dividend in my problem because that's the amount that we have. And they ship 4 DVD players in each box. So the 4 is my divisor. So let's look at this model it down here. Oh my goodness, that's an area model. Except for this time, we know what's on one side and we know what's on the inside. We're looking for what goes on the top. So let's think about this. I know that I have 2,125 DVD players, and I'm putting 4 in each box. So let's think. Can I make 500 boxes of 4? Yeah, I can, because 4 times 500 is 2,000. So I'm going to pack 500 boxes with 4 DVD players in there. So I'm going to pack them up by taking that 2,000 out from my 2,125. When I do that, I have 125 DVD players left to pack up. So I'm going going to move my 125 up here. So now, let's think. Can I pack 20 boxes with 4 DVD players? Yeah, that's 80. Maybe I could get a little bigger. Could I pack 30 boxes? Yeah, I could pack 30 boxes. You know what else? I could also pack 25 because I really like thinking quarters. So I'm going to think quarters, and I'm going to say 4 times 25 is 100. So I'm going to pack 25 more boxes of DVD players. So that's 100 DVD players that I'm going to take out from that 125, and that leaves me with 25 DVD players left to pack. So now I'm going to move that back up here. So I have 25 DVD players left to pack into 4 in each box. Let's see here. 1 box would be 4, 2 boxes would be 8, 3 boxes would be 12, 4 boxes would be 16, 5 boxes would be 20, 6 boxes would be 24, and I don't have enough to pack 7 boxes. So I'm going to pack 6 more boxes with 4 DVD players. So that gives me 4 times 6 is 24. I'm going to take that out of my 25, and I'm going to have 1 DVD player left over, and it's not going to make a full box. So that is my remainder. Now, to find out how many full boxes I shipped, all I've got to do is add up all these little pieces. Remember, I packed 500 boxes, and then I packed 25 boxes, and then I packed 6 boxes. So all I've got to do is add those up. 500 plus 25 plus 6. Well, 5 ones plus 6 ones is 11 ones. I'm going to keep my 1 and regroup my 10. 1 10 plus 2 10s is 3 10s. And then 500 plus nothing is 500. So I was able to pack 531 full boxes of DVD players. Now, that was the area model. Let's look at the same problem using partial quotients. Let's read that problem one more time. A factory has 2,125 DVD players to ship to electronic stores. They ship 4 DVD players in each box. How many full boxes can they ship? Now, with partial quotients and using that, we're going to use this little symbol to divide. Okay? Now, inside this symbol, I need to put my 2,125 DVD players that I've got to pack, and I'm putting them into equal groups of 4, so that goes on the outside. So you can see over here where we have it set up. So now, let's look at this one more time. Remember, I was able to pack 500 boxes of 4 DVD players, and 500 times 4 gave me 2,000. So I'm going to take that out. So 2,125 minus 2,000 leaves me with 125 DVD players left to pack. Now my next one, I'm going to pack 25 boxes with 4 DVD players, and that's 4 times 25. Well, that's 100. So I'm going to put that down there, and I'm going to subtract that from my 125, which leaves me with 25 DVD players left to pack. And my last little piece right here, I've got 25 DVD players left to pack. I was able to pack 6 more full boxes. So 4 times 6 is 24. I'm going to take that out, and that leaves me with 1 DVD player left over. And then all these little numbers on top are my partial quotients, and all I've got to do is add them up. So 500 plus 25 plus 6, once again. 5 ones plus 6 ones is 11 ones. Regroup my 110. 110 plus 2 tens is 3 tens, and then 5 hundredths is just 5 hundredths. So I was able to pack 531 full boxes, and I had one DVD player left over. Now, mathematical discourse. Let's think about this. In the model it, why do you subtract the partial products to divide? I'm going to give you a few seconds to think about that. Why do you subtract? Well, I think that we subtract because you were packing those away. I am pulling those groups out, so I need to separate it from my total. I've already sorted those, so I'm going to separate them. Remember the first one where I packed 500 boxes with 4 DVD players? Those boxes were packed, so I need to take that away. So that's why you subtract partial products to divide. Now, let's look at the Activity 2 example problem. The example says muffins are packed and sold in boxes of 4. How many boxes are needed to pack 260 muffins? So, I'm going to read that one more time because I'm a good reader. Muffins are packed and sold in boxes of 4. How many boxes are needed to pack 260 muffins? So I'm taking the 260 total muffins. That's going to be my dividend. That's why it's my first number here. And I am packing them into boxes of 4. So that 4 is my divisor. So I'm going to divide, and if you look over here, they put the 4 on the outside, and then we know we have the total of 260, and we're looking for the numbers that go on top. So if I'm packing groups of 4, can I pack 50 boxes of muffins? Yeah, I sure can, because 4 times 50 is 200. So I'm going to pack those 50 boxes. So I'm going to take that 200 muffins out, and that leaves me with 60 muffins left to divide. So I'm going to take that 60 and I'm going to move it up here. So now I only have 60 muffins left to divide. So I'm putting them into groups of 4 again. Can I make 5 groups of 4? Yeah, I can. That's 20. Can I make something bigger than that? Yeah, I can. Let's pack 10 boxes. 10 boxes of 4 muffins is 40. So I'm going to pack those 10 boxes and take that away from my 60 that I had. That leaves me with 20 left to pack, and I'm going to move it up here. So I have 20 muffins left to pack, and I know that I can put them into 5 boxes. So 4 times 5 is 20. I'm going to take that 20 away, and I have no muffins left to pack. And so all my little partial product quotients up here at the top need to add up. So 50 plus 10 plus 5 is equal to 65. I need 65 boxes to pack 260 muffins with 4 in each box. You're going to move on and do the other problems that you have on your Activity 2. Good luck to you today. Let's review. Today we multiplied and divided using place value strategies. So with multiplication, we know we have the area model that we can use right here. We know that we can use partial products, and we know that we can use the distributive property. Your sheet is going to have you using all 3 of these different strategies. For division, you know that we learned you can use the area model and you can use partial quotients. Now, is it okay if you are not the most efficient thinker yet and you have to take out 100 and 100? Yes, it is, because you're going to get to where you are an efficient thinker. All right.